Our first learning unit is on essentials of chemistry. So our first skill here is on qualitative aspects of matter and energy. So as we study chemistry, we're really studying matter and its properties and changes that matter can undergo. And so one of the things that's going to be important to think about is looking at things on both the molecular level, so seeing those molecules and how they interact, and thinking about what that looks like in our everyday world, the macromolecular level. We also want to be able to think about energy. And two components to energy that are really important is that thinking about energy is not really created or destroyed, it's just converted into different forms as chemistry happens. And chemistry always happens to have things go downhill in energy. So that's going to be a theme that we'll see as a thread throughout the entirety of the course. So as we think about chemistry from a qualitative standpoint, we can talk about things on a physical or chemical level. We can talk about physical changes and physical properties, or chemical changes or chemical properties. So as an example here, I'm going to talk about water. And so we can think about some of the physical properties of water. And again, those are characteristics that a substance shows without it changing itself. So a melting point might be a physical property of water. And the physical change that happens is water would melt from solid ice to liquid water. A chemical property of water might have to do with it changing into a different substance. So, for example, you could do electrolysis of water that actually breaks water molecules apart into its component hydrogen gas and oxygen gas. And so this is just a pictorial representation of sort of that same process. Again, thinking about a physical change with water, where we have solid water kind of melting to liquid water. And again, this is a nice image that kind of highlights the differences between what we see on a molecular level and what we see on a macromolecular level. And then again, with a chemical process, again, this electrolysis of water converts water into two different substances, hydrogen gas and oxygen gas. And so one of the important skills that you're going to have to be able to demonstrate is identifying whether or not something is a physical or a chemical property, or for a process, whether it's a physical or a chemical change. So phase changes are a very classic example of a physical change. And I'm going to introduce a concept now that we'll build on later in the course. And that's how we think about what happens on a molecular level with phase changes. So three phases that we think about, right? We've got solids, we've got liquids, and we've got gas. So I want you to envision molecules as a solid being molecules that sit very still. There's not a lot of molecular motion. They sit very close together and they're very ordered. And interactions between those molecules, intermolecular interactions, are what hold those molecules into that solid phase. Now, as we increase temperature, meaning we're adding heat, what we do is provide enough energy to allow those molecules to move around a little bit more. And as they move around and they weaken those intermolecular forces, we can get a liquid. Now, as that liquid increases in temperature, as we add more heat, what happens is we provide enough energy to overcome that interaction between molecules, and they can separate and then live in the gas phase. So thinking about phase changes is going to be something that, again, we see throughout several different chapters in our course here. So I wanted to introduce that concept early and have us build on it throughout the course. So speaking of these concepts of heat and temperature, I want to make sure to highlight here the difference between these two terms, which might have some kind of interchangeable use, but they are distinct. So temperature really reflects a relative difference in hotness or coldness, if you will, of a substance. And heat is what happens as the energy will flow from a substance that's hot to a substance that's cold. And we define heat as Q. And we're going to do a lot with heat throughout the entirety of this course. So as we measure temperature, there's three ways, again, to measure temperature. You're probably most familiar with Fahrenheit. We think about body temperature being 98.6. We think about a cold morning outside might be 30 degrees, but a hot afternoon might be 90 degrees. So Fahrenheit is a very familiar temperature scale, but we're going to focus in chemistry on two other temperature scales, the Celsius scale and, importantly, the Kelvin scale. So I want to introduce these, how we interchange between them, and how and why we have these two different scales. So again, the Celsius scale might be familiar to you as well. Two numbers that I want you to know, actually probably three numbers that I want you to know, is that the freezing point of water is 0 degrees Celsius, boiling point is 100 degrees Celsius, and I do want you to know what body temperature is. That's 37 degrees Celsius. So three numbers that I'd like you to know. And again, here we can see that there's a 100 unit difference between solid water and then gaseous water. So the Kelvin scale really just takes that 100 unit difference and shifts it up. To convert between Celsius and Kelvin, you're just going to add the number 273. Exactly, it's 273.15. But what it really does is it takes that unit difference and makes it so that there's no negative numbers. And that's important from a calculation and a mathematical standpoint, that we never have negative numbers for some of our calculations, which is why we're going to rely on the Kelvin scale for a lot of our work. The last thing to just kind of talk about qualitatively is a few other terms: mass, weight, and density. And mass and weight might again be some terms that are used a little bit interchangeably, but they're different. So mass is really something that's constant, and it reflects the quantity of matter that we have. So for example, an astronaut might have a mass of 100 kilograms. That mass is going to be the same whether they're on the Earth or on the moon. But what will change is that astronaut's weight, because weight is variable because it depends on the gravitational field that that matter experiences. And that gravitational field is going to be less on the moon because the gravitational pull is less. So again, a little bit of semantics there, but I want to make sure you understand the difference between mass and weight, and understand that we're always going to be talking about units of mass when we deal with chemistry. So mass is another important piece here. We're going to talk about mass as it relates to density. Density is really a relationship between the mass of an object and the volume that it takes up. And so again, we've got a relationship between two variables that'll give us density. And a concept that I want to introduce right now is this idea of how things are related. So for example here, say that we were to increase the mass of an object, but leave its volume constant. That would mean that the numerator here was increasing, and that would mean that the density of that object was larger. So the mass is going to be directly proportional or directly related to density. Increase the mass without changing the volume, and you're going to increase the density. Let's think about that same thing here if we increase the volume. If we increase the volume, that means we're making the denominator larger. By making the denominator larger, this overall value becomes smaller, and density will thus go down. So in this case, increasing the volume means we'll have an object with less density. So that same mass is going to be taking up more space, so that object is less dense. So we'd say that those are inversely proportional. And understanding the relationship between things that are proportional in a direct standpoint or in an inverse standpoint is going to be really important as a qualitative skill for us to predict things in the future. So that's our first skill here on qualitative aspects of matter and energy.